Test. All right. So, I got a 3D printer a long time ago. Well, not a long time ago. Maybe 2 months, 3 months ago now. And ever since I started 3D printing, FDM 3D printing, I wanted to simulate and know how strong my materials are. And the craziest thing is, this is just not supported. You know, like the slicers don't care, the modeling doesn't care, the CAD doesn't care. Nobody really cares about the strength of FDM printed parts. And I think everyone just sort of takes FDM as a joke. So I've been thinking for a long time, like, okay, look, we know the tool path. All of these slicers, what do they output? They output G code. And that's basically tells us the information of when it is depositing material. And so the craziest thing to me is that there's really nothing that out there, I mean, except for some, like, you know, it's not popular is what I'm saying, is to take a step file, a 3D model, something from a CAD program, then slice it, and then re-export the sliced model, you know, with infill and all of that, back into either a mesh or something else that you could then use to simulate. And so, you know, this keeps popping up in my head week after week. I finally stumbled on this great paper called Geometry Reconstruction for Additive Manufacturing, from G-Code to 3D CAD Model. Now, I was thinking this morning before I found this paper, okay, I'm just going to do this thing myself. And the way that I would do it, if you think about it, okay, you know the nozzle diameter and you know the layer height. So the simplest possible thing you could do is just, for whenever the extruder is on, you just place a little rectangle for wherever that extruder is, and then you can just build a model up. Now, there was a number of unanswered questions with that this paper solves that is like genius. And I'm like, it gets rid of all of the problems I feel like that I'm going to have in actually getting this done. So one thing is, can I just use their thing? And so, no, because it's like, first off, you need MATLAB, then you need Python, and then you need to do it in FreeCAD. So what I imagine is the next, you know, it just seems like how things go, is someone does it in academia and they do it in like some bubkiss donkey way. And then someone who actually wants to get things done does it again, and it's still bad. And then the third time, maybe it's okay. But like, I would like to be that second time. And there is something out there. I think it was called like G-Code to STL or something like that. And this seemed okay. It didn't seem open source from the about page. I don't really know who's doing this, you know. But it does sort of get done what you want it to do. But I just don't like the format of it. I don't like how it's done. So we're going to do it ourselves. And now I will say the killer insight to how this paper works is, instead of trying to like figure out how to do the reconstruction, you just offload all of that to a CAD program. So you basically take a profile and you just use the sweep tool and some automation to sweep all the profiles where the extruder is on. And you know when the extruder is on because that's just how G-Code works, is there's an on button or an on command. So let's just read a little bit of the paper. I don't want to read that much of it. So here's the overall procedure. You take a G-Code file from some sort of slicer, then you extract the toolpath coordinates, which honestly I don't really know what that means. So let's see. Okay, here we go, methodology. The methodology developed in this research aims to generate a step file representing the real printed geometry as output given a certain G-code as input. The step format enables a comprehensive product. Okay, Jesus. To reconstruct the true geometry coming from the FDM process, the authors propose to exploit the capabilities offered by the sweep command available in every CAD package, except for Zoo, obviously. Also, I think that if I do this right, I can make this one, like an actually useful tool, which I have yet to do in my life, and um, two, the YouTube video for it basically writes itself because, well, here's the tool would, like G-code to STL, would work with a bunch of different slicers. So if you have a printer and you have a slicing workflow, you can just use that. And then on the other end, and I think I'm gonna write the G-code stuff and the sweep export thing in Rust because it just seems like a good choice. Except for the fact that I don't think that there's that many good G-code libraries, so maybe I'll write it in Python. And then on the back end, what that's really great is that we're going to write scripts. We're going to write a way for all of these outputted files to be read in by Fusion, by Onshape, by FreeCAD, and let's see source code. Yeah, it's crazy that they don't like say we have provided our source code. Anyways, but so then basically you can use any slicer that you want, and you can just use whatever simulated CAD program that you want. So I really feel like that'll help it take off, and then the video will go with it. Okay. Yeah, so the sweep command is ideal for the suggested methodology's goal, and it really is. Read the G code. I don't know what a stringer line is. That's not a common thing. G0 and G1 and the layer command. Okay, so start, stop, and then layer. And is that actually in the G code? If we were to take just whatever my most recent Bamboo model is. Okay, yeah. Once the toolpath coordinates are available, a Python code has been developed to provide a list containing all of the sweep path spines to be generated. At this level, just the movements involving the material extrusion should be evaluated. It's vital to distinguish between situations where the nozzle is extruding material and situations when the nozzle is moving to a different coordinate without printing. What the hell are they talking about? It's vital to distinguish. This is done by exploiting the flag values available at 2 consecutive lines. Oh wait, can I open up this? Okay. Export plate slice file. G code. Okay, so let's just .3mf though. Is this binary? See, that's no good though. Okay, so wait, no, but that's a G code 3MF. See, oh, you know what it is though? Okay, so this is the G code. Okay, so there's a whole bunch of, it's crazy how long this is. But so we want to search for layer. Oh wait, I found a It's honestly not a bad idea. Fuck it, I don't care. I don't see any actual command with layer in it. Wait, how do we know that the extruder is on? Oh wait, let's What if we did this? Okay, so this is simpler. Oh. There's 2 layers, so that's, yeah, okay. Is there infill at all? Yeah, there is. What's a G0? The hell is that? Okay. All right. So let's just copy the method down as basic as possible. It contains layer, though. Okay, wait. Can I download Cura? Do I have Cura? Oh, yeah, and then I want to do bamboo. Dude, why would Firefox think that this is okay? Just so fucking crazy. It's just so fucking crazy, bro. They just want to feed you junk. It's probably this. Oh wait. Oh, I didn't even know about this. Wait. I didn't even know about that. I've never calibrated my machine either. I heard that's supposed to help a lot though. Okay, so it's probably okay, so how to export the config. Export slicing data. So let's just try this. So, but if I do this, I hate that, dude. These start menu things that you gotta follow it. Presumably, I can just do this. So I'm just gonna put this. Oh wait, can I do this? Hmm. But where is it? Where is the CLI? Okay, well, let's just try to see if it works. So let's copy. I'm just gonna. I'm gonna take. Uh, dude, why do they never? It's like file extensions are too complicated for people. We should just hide them in this freaking weird. Okay, so this is a step file. So we want to copy this. Wait, what do they say? They want a 3MF? Is that what it said? Slice 3MF. It should work. So let's go to this and just drop it here. Oh. Okay, what if we do this? Copy path. Can you do that? If I just do this in a terminal. It just returns the... But how do I don't know how to escape. I never know how to escape. Is that it? So if I do this from here, okay. So now we just need to, this, and then what is the full command? This is going to be, wait, output at the test data moon. Okay, so we're gonna do this. Part studio. Can we just rename this fucking thing? Okay, so it did that, but I want the G code. The last edit to this page was on November. Oh, wait. That's so fucking annoying, though. Dash H didn't work at all. Okay, so how do we get G code out of this thing, man? Does this just prefix it? What if I add this? I don't think that's gonna do anything with a G code, though. Oh, and it did. So sick. Okay, so this is the command. All right, we have G code. These are all the actual machine settings. And then the rest is just 500 more lines, right? Yeah. Okay, so we have it. Cool. So copy path. Okay, so now, format error. I don't know what error you're supposed to use. I think it's just that, right? Awesome. But we need to be. Okay, I don't even really want to follow this paper too closely because literally all. Oh wait, can we add this? For right now, I actually don't care, but I want to add it just in case. Oh, it's a hot one, bro. It's a hot one. Doesn't the Oh, this is the step file. I'm talking about this. Doesn't the Okay, let's just see how does it start out for real. Doesn't have any of these codes. Return to home. What does the F thing mean here? Bruh. Oh, the feed rate? Yeah. Okay, so it's just okay. So I guess yeah, so if you want to improve this in the future, you have to take feed rate into account so that you like do something with layer adhesion or something. I don't know. Set nozzle temperature, G90, absolute positioning. Yeah, doing it all in okay, cool. Metric. Oh, that's so cool. Okay. Okay, change layer height. So Z height, layer height. So maybe that's how they do it. They just rely on the comment. That's so funny. Is there a documentation of the G code that... Where can I find documentation about the G code that Bamboo Studio generates? Oh, this is cool. Is this on GitHub? Yeah, see, what was I looking at? M106? Set fan speed. P. Oh yeah, which fan to use? S. Speed. Wait, this turns it off though. Okay, M204. Set starting acceleration. Okay. Then the G1. What is this E? Okay, what does this mean? Oh, minus 0.8. What does the E mean? So what does that mean for a non... Like, what does that mean for a cutting device? What would that mean for a cutting machine like a mill, though? Yeah, so E is just for a 3D printing. Okay. So that's all good. So E minus, so it's retracting it, right? Retract. Okay, there you go. Cool. M73. M73. Oh, that's not going to work. Set print progress. Oh, okay, that's fine. Okay. G1. But how do we know whether or not it's on or not? That's what I'm saying, though. Like, this thing has to do a lot because it has to also figure out how fast it wants to move. Like, you don't want to just move at maximum speed all the time. Can we look at it? Can we see? Okay. So what was M73? Oh, it's a progress. M73 is progress, right? So does it wait until it's done extruding before it moves on to the next command, or is it you extrude 0.8 and then it starts moving while it does that? Oh, wait. Oh, I'm blind. I'm blind. Okay. Is this just scaled to the distance? We're gonna like simplify this and just calculate this position. So what we want to do is to very start is just let pos vec equal vec. Then we say for wait how do we read? How do I read a text file or a G-code file in Rust and just get each line as a vec of string? Dude, no. How do I do this as short as possible? Okay. I'm happy with that. That's fine. It's not ideal, but whatever. Oh, wait. Okay. Wow, I can't believe I made that mistake. That's actually really silly. Oh. Dot flatten, what does that do? Okay, I don't give a fuck. Okay, so now. Dude, I need Copilot again. Oh yeah, so okay. So let me give you the spiel because I'm actually quite excited about this. If you're are you still here, bro? Robotocracy. Okay, so now let's just wait, what's the difference between G0 and G1? Okay, so here's what I think we should do. Yeah, basically we want a vector of tuples of xy tuples, but each of okay, so that would be like the split up there would be all of the like continuous moving extruded parts or something like that. But right now let's just okay, so G1 are the kind of the ones that we want. G0, okay, so if we go to the Merlin docs again and then we look up G0, I don't know if you can for all subsequent moves. Presumably they don't take advantage of it because it's goofy as hell. Oh, but you can extrude in, but okay. But it looks like you can extrude on a G0. When would you do that? Okay, so wait, let's look at all the G0s in here. There's no G0s in here. Okay. That's just because it's on all the time. That's just because this model just happens to be on all the time. So let's look at, do we have more G code here? So let's look at G0. Oh, wow. Wait, but that's like a, yeah, that's like a, something else. Oh, wait. Yeah, I don't know that program. That's some weird thing. What is this? This also ending codes. We want something in the interior. Let's see, wipe nozzle. Let's keep going. Oh. Oh, wait. Wait, what model was this? This was also probably a single... Okay, wait, so what if we do this? in here we're gonna do another sketch. Yeah, okay, that's fine. And we're just gonna, it's gonna be two bodies, but it's like who really cares? So okay, great. So now we can export the step file, and this is going to be two body test, and we're going to just see if we can find a G0 on the in the interior of save as print sim. Yeah, so two body test. Okay, so now we get to do this cool thing that I know about. Now I know how to slice. So this is going to be two body test dot step, and this is going to be, let's see if it'll make the dir. So we're gonna call it two body. Let's see if that works. I think you have to make it first. It's crazy how ridiculous that is, but whatever. No. Oh, you know what? It probably is. Wait, two body test dot step. Did it like weirdly fail? Can we try this again? Okay, so that didn't work either. So something's being goofy. But I don't know what it is because I literally just... I feel like I just ran this. Okay, what if we get rid of this one again? Dude, what the hell? Is it because this Orient flag? Oh my god, I'm so annoyed. Okay, so we need to just change this to be two buddy. Okay, should be good. Wait, can I just delete everything in here? Run it again. Okay, so let's try to find a G0. So then I guess you just have to find G1s. Can I load a G code into the slicer? Import. Okay, so I made a little test where I have two small rings that are like 0.4 millimeters high, and they're disjoint, they're separated, because I was trying to see where it does G0, but Bamboo doesn't seem to output any G0 in that case. So, oh yeah, I want to know. Okay, so let's just find if there's a G one that doesn't extrude it. Okay, so can you write a little write a minimal okay. Write a minimal function that parses these G1s, and I guess for like Z and E it has options, and then after you write that function, write another one that takes the list of parsed G1s and then finds all the cases where E is none, is option none, because I want to see if when it moves to the second disjoint body, if it's just doing G1 with no extrusion. Yeah, perfect. Perfect. Yeah, that's the dead simplest code that I could think of, and that's what I like. So that's good. I don't care that it's like really verbose at the moment, because it's not really a big deal. So we want to do this. If line starts with, then let G1 equal parse G1 line. Is that gonna work? Consider borrowing. Okay, that's fine. And then why is there an option in the case that it fails? Okay, let's do this. And then pos vec dot push G1. Oh. And then we wanna do oh, it didn't write the other one for me. Wait, where was this? Where's the G1 with nothing? I am looking at the right thing. That's at the very end. I mean, yeah, it's got to be at the very end. Am I also running on the right code? Wait, really? It's at the end? No, that's not right. Can we look at this? See, this doesn't seem right. Is it just like sorted weird? What the hell is going on here? I think it's just like doing something weird when it fails to parse. But this code seems... Okay, so this is the only case where it returns none, so that's fine. But then it doesn't find these X, Y, Z's. I don't get it. Oh wait, can we just print out all of the G codes actually? So that's allowed. And then we want to print... So this is like, okay, so the last one, the very last one. Yeah. Okay, so I think I'm good now. Yeah, and we just don't have the feed rate thing. But I don't think we need that. Okay, so let's just concat all of the X and Y's. Okay, wait, so is there ever a case where X is something and Y is not something? Now help me answer if there's ever a case where X is something and Y is nothing, or the opposite, where Y is something and X is nothing. Or does G1D require both? That's so goofy. But I don't really care. We just want to know. So that's a vec of G code command, so that's good. No, can we just, okay. All right, so let's run it. Not found in the, oh yeah. Let's just change this to parse. Oh wait. Wait. Okay, so there was nothing. So I'm pretty sure that. Wait, but can we do another test? Do dee dee ba da beta below. Do do dee da ba da ba da. Okay, so now we have a straight line here. Okay, so this is going to be called. So wait. Oh, let's test it. Oh wait, hold on. I gotta get rid of this thing, man. So let's just see if we can straight line test, and then we want to make this. Oh, it's because I had the freaking orient in there. Wait, can I delete this? I just want to know if I have to do this annoying thing every time. Okay, I guess I do. Okay, and we have to add that output dir thing. Okay, so here is the working command. Don't fuck with it. Okay, so what do I want to find? Okay, so now I just want to update this code to refer to straight line test and see if it ever does. Oh shit, I didn't mean to do that. I meant to do this. Okay, I think okay, well it seems like whatever G code Bamboo is generating, they never like to do X without Y or Y without X. They pretty much just always specify. I did a little test with a square that has straight lines, and I thought maybe it would do that, but it didn't. Yeah, I agree. So now all we need to do is so are there any movements? So wait, but we want to know, okay, now are there any movements where X and Y are some and E is none? Okay, now write something that shows me all of the times when E is none, but X and Y are some. Some. Okay, so these are the commands where oh, and then here. Now see, that's interesting that Z. Wait, but Z. Hold on. Okay, wait, can we do this? Now that we're getting the hang of it, I'm going to take this extrusion, and instead of this, I'm going to make it 1. And then we're going to export it again. There we go. Okay, there we go. You can see these. So, okay, so all we need to do is, I mean, this is pretty much all you need are the G1s. Mm. That's so cool. Right. So there's where it starts at Z.2. All right, now that I know a little bit about what's going on, maybe I can just ask GPT to Jesus. Um, okay, so I need to just ask it to do the whole thing now because I feel like maybe it would be able to do it. Okay, so now I want a sort of broader program, one that reads in the G code for the printer, but then it gives me basically a bunch of paths separated by layer. So let's just take the first layer. It gives me a bunch of paths, and the paths that it gives me are the places where it's depositing material. And then you just get that for every layer, and that allows you to start the reconstruction process. I'm pretty sure all we need are G1s. I think that's literally the dumbest, simplest thing. Yep, and then this is all we need there for layer changes. Okay, so we're gonna do this. We're gonna do this. Wow, this is so many fucking errors. Okay, and then we'll need to define the sweep profile geometry, but that should be easy. Do I even have FreeCAD on here? I do. I feel like I'll start with FreeCAD just so that I can reproduce the paper. Bam, which, okay. All right, come on, come on, come on. Sick. Oh wait, we need to just fix that. Okay, so now we just want to make. Okay, so now I just want to great, now make something. Wait. Great, now can you make something where I can visualize the toolpath? Why did it switch to Python? $2D plots? Dude, no. Okay. Okay, never mind. Let's use Python. But how do I export the results from the Rust code? Because I need to write it out and then read it into Python, presumably. Ostensibly. Ostensibly. Oh, wait. My JSON.json. Okay, so now we have a JSON file that just stores it all. So that's great. Okay, so now, okay, now write the code to read that JSON in and visualize it. Oh shit. Is this gonna work? Dude. Dude, Python is such a fucking dog shit language, bro. Fuck Python, man. That's so insane. Is this gonna work? Did it open anything though, or? Okay, sick. Can you add little arrows so that I know where it's moving? Let's see, is this gonna work? Python viz.py. Does that work? Okay, nice. Okay, I get it now. So this I don't understand at all. Is this only doing the first layer or something? I can't zoom in or anything. What the fuck is it doing, bro? Oh, wow. Should I do that? But don't I need to, first I need to... Personally, I don't really like this stuff, though. Oh, shit. What the fuck? Where the hell is it, man? See, and now I can't, like... This is pretty cool, though, that it was able to do that. Why doesn't it show it, though? Oh, wait, don't you have to do this? Oh my god, that thing is so annoying. What's this? And they make it search with Bing, dude. Hide menu always. Can we just change this to this? But you can't zoom in, so it's like, whatever. But I just don't understand where we missed stuff. Why did we miss all of these things? Also, wait, does this output only the... Okay, I need to make some food, because I got class today. But we're making progress. I sort of understand G-code. Soon we will have something for the masses to simulate FDM parts. And that'll be sick. It'll be so cool. And hopefully we'll get to actually doing the test to see if, like, we can actually model or, you know, correctly model FDM parts and get their stresses and strains and deformations way more accurate. Because what are we going to do? Print at 100% infill all the time?